Section 4.7 Video 2, Odds, Expected Value, and Binomial Experiment. In this video, we will cover the following objectives: calculate expected value and solve problems involving expected value. Expected value is a number that represents the anticipated long-term average of the outcomes if an experiment is repeated over many trials. To calculate expected value, there's a few things that are needed. We first need to know the results of an experiment. So, for example, result 1, result 2, result 3, all the way up to the final result possible. Each one of those results would have a corresponding respective value. So result 1 would have a value 1, result 2 would have value 2, and on and on. To calculate expected value, you would take the probability of a result times its value. And you would keep repeating those products, probability of a result times its value, until you reach the end of the results. And at the end, you take the sum of all of those individual products. Let's look at an example. Example 4. At a carnival, Andy plays a dice game where a player rolls 2 dice and wins prize money based on the numbers rolled. If the player rolls a sum less than 5, she wins $20. If the player rolls a sum from 5 to 9, she wins $5. And if the player rolls a sum higher than 9, she wins $10. Find the expected value of the dice game. Let's begin by finding the probability of a sum less than 5, the probability of a sum between 5 and 9, and the probability of a sum that's greater than 9. We could write out the different rolls. So for example, a sum less than 5, the roll 1, 1 would work, or 1, 2, and we could keep going in an orderly fashion. I went ahead and put our table of first roll compared to second roll, so maybe it would be a little quicker just to highlight the ones that are the sum less than 5. I'm going to highlight the sums less than 5 in pink. So the roll 1, 1, 1, 2, 1, 3. I'm not going to highlight the roll 1, 4 because that would be a sum equal to 5, and we just want the sums less than 5. Roll 2, 1, 2, 2, 3, 1. All of those are rolls that would have a sum less than 5. And if you count them, there are 6 of them out of 36. And so our probability is 6 out of 36. Now I know 6 out of 36 does reduce, but I'm going to leave it 6 out of 36, and I'm going to reduce when I get to my final expected value answer. Let's highlight and calculate the probability that the sum is between 5 and 9, including the sum of 5 and the sum of 9. So highlighting in blue, roll of 1, 4, 1, 5, 1, 6, 2, 3, 2, 4, 2, 5, and 2, 6, 3, 2, 3, 3, 3, 4, 3, 5. I'm also going to include 3, 6 because that's a sum of 9. 4, 1, 4, 2, 4, 3, 4, 4, and 4, 5. 5, 1, 5, 2, 5, 3, and 5, 4. 6, 1, 6, 2, and 6, 3. And if we count up all the blue highlighted representations of our rolls, we end up getting 24 out of the 36. And again, I'm going to save reducing that for later. The sums greater than 9 would be the remaining ones, or a roll of 4, 6, 5, 5, 5, 6, 6, 4, 6, 5, or 6, 6. And notice that there are 6 of those that have a sum greater than 9, or 6 out of 36. One advantage to saving our reducing for later is we can now look at 6 out of 36 plus 24 out of 36 plus 6 out of 36 gives us our total of 36 out of 36. Now that we have all of the probabilities, we want to know the value of each of those. So the value that Andy wins if she rolls a sum less than 5 was $20. The value for a sum between 5 and 9 was $5, and the value for a sum greater than 9 was $10. So we can calculate our expected value as the probability that we have a sum less than 5 times the value. We're going to repeat that for the probability of a sum between 5 and 9 times its value, and the probability of a sum greater than 9 times its value. The probability of a sum less than 5 was 6 out of 36, and its value was $20. The probability of a sum between 5 and 9 including 5 and 9 was 24 out of 36, and its value was $5. The probability of a sum greater than 9 was 6 out of 36, and its value was $10. And now we can simplify as we go. I sometimes like to simplify each product first. So here I could take 20 times 6 and make it 120 out of 36. 24 times 5 also ends up 120, 36. And then 6 times 10 out of 36 would be 60 out of 36. For a total of 300 out of 36. Or if we take 300 divided by 36, we get a dollar value of $8.33. So the expected value of this dice game is $8.33. If Andy were to play for a long time, she could expect to win about $8.33 on average. Let's try example 5. What if we use that same scenario of the dice game, but now Andy has to pay $8 to play the game? How does that change our expected value? The probability of a sum less than 5 would still be the same, 6 out of 36. The probability that the sum is between 5 and 9 would also stay the same, 24 out of 36. And the probability that the sum is greater than 9 would stay 6 out of 36. What's changing is the value. The value of a win when rolling a sum less than 5 was $20, but if Andy has to pay 8, then how much she actually gets to take home would be 12. The value of winning between a sum of 5 and 9 is going to be the $5 that they would have won, but we're going to deduct the 8 that had to be paid to play the game, which is now a loss of $3, which we could designate as a negative. The value for rolling a sum greater than 9 was $10, but again, to pay 8 means that the take-home would only be 2. So we could take and find our expected value by taking the probability of the sum less than 5, 6 out of 36, times its value, which is now $12 because 8 had to be paid to play the game. The probability of a sum between 5 and 9 was 24 out of 36, and its value is negative $3, or you end up paying more than you win. And the probability of a sum greater than 9 is 6 out of 36, and the value there would be $2 for a win. Simplifying, we get 72 out of 36. In the middle product, we end up with negative 72 out of 36. And the final one, 12 out of 36, which simplifies to be 12 out of 36, or as an expected value, 33 cents. Example 6. On a U.S. roulette wheel, there are 18 red numbers, 18 black numbers, and 2 green numbers for a total of 38 numbers. Amani placed a $75 bet on the number 20. If betting on a single number pays 35 to 1, what is the expected value of the game? And we'll also discuss, is the game in Amani's favor? Looking at a single number paying 35 to 1, let's discuss what that means. One way to interpret that would be the 35 is multiplied by the bet value for a win. In this case, the bet value is a $75 bet. So if the ball ends up spinning and landing on the number 20, then Amani would win $35 times $75, or a total of $2,625. The 1 represents 1 times the bet value that a person will lose if, in this case, the number isn't spun to be the number 20. So 1 times the $75 would be $75, but because it's a loss, we represent it as a negative because they're losing $75. So let's look at the probability of spinning a 20 times the value of spinning a 20. And then we also have the probability of not spinning a 20 times the value of not spinning a 20 to find our expected value for the roulette game. The probability of spinning a 20 is one single number out of the 38 possible. And the value we said was going to be 35 times the bet value of 75 for a total win of $2,625. The probability of not spinning a 20 would be the other 37 out of the 38 numbers. And the value is that the person would lose their $75 bet. Together, simplifying, we have 2,625 out of 38, and 37 times negative 75 is negative 2,775 out of 38, for a total of negative 150 out of 38, or an expected value of negative $3.95. So if played over the long term, on average, Amani would lose $3.95. Because over the long term, she is losing money, this game is not in Amani's favor. It would be in favor of the casino where she is playing. Example 7. Expected value doesn't always have to be in betting situations. Okay? Laura is typically an A student. She heard that Professor Sherman uses a grading curve, and so she wants to take that class. In Professor Sherman's chemistry class, 10% of his students receive an A, 25% receive a B, 30% a C, 25% receive a D, and 10% receive an F. If Laura's school uses a 4.0 grading scale, determine her expected grade from the class. Also determine if it's in her favor to take this class. Note that an A on a 4.0 grading scale is worth 4 points, a B is worth 3 points, a C 2 points, a D 1 point, and an F receives 0 points. So we want to look at the probability of earning or receiving an A times the value of an A. And then we're going to do the same for probability of a B grade times the value of a B plus the probability of a C grade times the value of a C. And we're going to continue that with the D grade and an F grade. So The probability of receiving an A was 10%, or as a decimal, 0.10. The value of an A is a 4.0 GPA. The probability of a B is that 25% of the class receives a B, and the value of a B is a 3.0 GPA. The probability of a C was 30% of the class, and the value of a C is a 2.0 GPA. The probability of a D is 25% of the class will earn a D and have a 1.0 GPA. The probability of an F is 10% of the class will receive an F, and that is a 0 grade average. Simplifying each one, 10% times 4 would be 0.4, 0.75, 0.6, 0.25, and then 10% times 0 would be a 0. Combining this all together, we would have a 2.0 GPA, or a grade of C. Since Laura is typically an A student, she may not be happy with earning a grade of C, and so it might not be to her advantage to take this class. Example 8. The Sparks Shoe Company plans to create a proposal in an effort to sign an exclusive contract with the 2023 basketball star. Sparks will spend $250,000 on creating a proposal. However, there are 5 other shoe companies expected to make presentations to the same basketball star, so winning the contract isn't guaranteed. If Sparks can sign an exclusive contract with the basketball star, the shoe company estimates they will earn $1.2 million in revenue from shoe sales. Find the expected value for this business decision. Let's first highlight that there are 5 other shoe companies, so that really means there are 6 companies total, the Sparks Shoe Company and 5 others, making presentations. The other thing we want to look at is how many outcomes are possible. There are 2 outcomes. They're either going to win the contract or they're not going to win the contract. We need to find the probability of each of these 2 outcomes and also their dollar amount that they would be worth. To win the contract, only 1 out of the 6 companies will win the contract. The amount that the contract would be worth in this case is $1.2 million, or $1,200,000, but we have to remember that they're going to spend $250,000, so we want to take that away to have only what they would take home after the proposal. And then we'll work on the same probability and value of not winning the contract. To not win the contract, the other 5 out of 6 companies will not win, and in this case, they would spend $250,000 but not make anything on shoe sales, so they would not make anything on shoe sales but spend $250,000, which ends up being negative. Simplifying here on the left, we get 1/6 times 950,000 plus 5/6 times negative 250,000. And since we're working with money, we can go ahead and simplify. 1/6 times 950,000 ends up being $158,333.33, rounded to the nearest penny. And 5/6 times negative 250,000 would be negative $208,333.33, for a total of $50,000, and that is positive. So they would have a net gain of $50,000 in the long run with making decisions like this. So in the long run, over time, the company can expect to gain $50,000 for this type of proposal. So it would be in the best interest of the company to make this decision and make the proposal. And that ends example 8.